Welcome guys to part 2 of 4 video series. This is the drawing sheet number 5, the lift slider mechanism. I just cut off the strips and cutting the smaller parts to size as per the dimensions in the drawing. This is part number 23, which is the bottom of the housing, and I'm just testing the parts, then I'll go up later. And it goes something like this when assembled. I put on shims between the slider head and the rails. I use the slider head as a spacer to keep the rails perfectly aligned. I'll gear up the head assembly parts and then I'll drill the holes for the long nut and steel pipe. This is how it looks like when glued together. I drive some screws to secure the head assembly and bore the holes for the long nut as well as the bushing for the lift arm. I bore the holes for the bearing using a hole saw, and then I drilled halfway through, embedded the bearing into the hole, then slide in that long threaded rod all the way through from the front side through the slider, through the rear carriage housing, and lock it down with 2 nuts on both front and back of the housing. Once the slider are in place, I finish the housing assembly and testing out if the bushing holes are aligned with the carriage. The radius there was quite small, it was touching the inside panel of the housing and might need some sanding to make the radius a bit bigger, about 2 to 3 mil. These are the parts of the lift mechanism, left and right arms. This washer serves as a lock so that the shaft would not slide out when the blade is tilting. Make sure that it's smaller than the shaft itself. 12 mil would be enough, but be careful, don't break the plywood. You won't see this in the drawing, that hole. Just drill a 6 mil hole in the middle and use a 12 mil Forstner bit to make a hole halfway through, then insert a 6 mil washer. Same as the other one, this is a lock washer secured with screws, and I recess it to make it flush so it won't hit the side of the carriage housing. This is the 12 mil shaft connecting the carriage, 14 mil shaft connecting the head slider, right arm with 16 mil bushings inserted on both ends, and 6 mil hole in the middle with recessed hole and a washer. I had some problems securing it, hence the hole marks. I was overthinking, well, I just can simplify by applying epoxy glue. So let's form the left and right arm. Insert the threaded rod in the middle hole and secured with 2 nuts on both ends, like that. Do not over tighten them so that they would work independently, and that way the load is evenly distributed to both arms. Now I can place this arm slider, but there are just some cuts we need to make on the carriage. Then here I'm aligning the holes, then I trace the shape of the arm, the end of the arm with pencil. Then I'll offset the pencil line for about 2 mm outwards for some allowances. And this is the part that I needed to remove. Then I'm gonna unscrew and disassemble the carriage and make the cut. The tip of the lift arm was nearly touching the rail slide, so I'm just gonna mark it up, eyeballing roughly around 1 mil of the rail, something like that, or 2 mil, or then I'll trim them off with a sandpaper. Yeah, and right there, I think that's good, and that's about 1.5 mil of the rail. After that, I finally glued up all the sides of the housing, then I'll test fit the lift mechanism parts, making sure that nothing is clashing within the housing. And after that, I finally glued up all the four sides of the housing, then I'll test fit the lift mechanism parts, making sure that nothing is clashing within the housing. And assembling these parts are a bit tricky. It's actually a struggle as I only have an access on this side of the housing and I don't want to make an opening on the other side as too much dust might clog the slider mechanism and it would also weaken the structure of the housing. And by the way, I cut a small arc there for the lift arm mechanism easy access. Then I tested it a couple of times and it worked so well. Now it's time to cut the trunnions. Okay, I made this quick sophisticated circling jig for the router and mark up the pivot points for the trunnions. All measurements are in the plans, but I'm just gonna show you how I made or how I went about with mine. I trust that you already know how to use a router. Otherwise, there's a lot of videos up in YouTube. It can be learned easily with some practice on a scrap of wood. So here I'm just gonna start routing from left to right to avoid tear out on the wood. I really don't like using this power tool, it's so loud and dusty, but I don't have a choice as this is the only guy who could do a precision cut that we would like to achieve. By the way, I got the idea of using wooden trunnions from one of Matthias's blog posts in his website 2 or 3 years ago, maybe somewhere around that time. You know him. It's about tilting table on a wooden trunnions that he made. It was nice. The link is in the description below. I have designed very simple machine before with trunnions. That was at work. It was made of steel and I was really surprised that wooden trunnions would work as well, if not better. But I still have plans on using steel trunnions in the future without any welding work involved, and I will see if I'll be able to pull off a design that will work. Okay, as mentioned in part 1 video, the trunnion scale is 1:1. I just printed them out and cut along the lines and overlay it onto the plywood and started cutting with the router. Anyway, I'm done now cutting the trunnions. This is the rear lower part trunnion and the rear trunnion, and above are the front trunnions. From the pivot point to there is 18 mil. Then I'll cut it on these lines, then cut off the curve with a coping saw. And here are they now, as per the parts list. Item numbers 8, 9, 10, 11, 17, 18, 20, 99. Front trunnion parts on the left and rear trunnions parts on the right. This was supposed to be the rack and pinion that I'm gonna use for tilting mechanism with tilt handles on the front as part of the original plan. But I ran into some difficulty as I don't have the materials and tools to make a really fine-toothed gears. I have plexiglass that I can use and make a drivetrain out of it, but it's not a common materials that you can buy easily, and I guess a lot of people will be left behind, which kinds of defeat my purpose. Bandsaw will do, but I don't have it right now as I still digital plans of the moment. But the idea is really cool. I actually made it work, but not in the best result that I'm expecting. I was making a very slight jagged movement or bumpy, so I dropped the idea and used it as a lock instead. Yeah, so this is the front cabinet that I cut in the exact sizes in the earlier part of the video, and I'm just transferring the details onto the plywood. And here I'm attaching a piece of plywood on top of the cabinet to make a temporary extension so that I can put in there a nail as the pivot point for cutting the arcs slots by using the router and circling jig. Once done marking up, I'm just drilling the end point of the arc slots on both ends with a hole saw, then I proceed with cutting it out with the router. Then I'll make the hole saw cut all the way through to completely remove it.